And chapter 12 about hash table. Hash table. And if we scroll down in the previous chapter, I think it was chapter 3, we have looked into various searching techniques. Consider problem of searching a value in an array. If the array is not sorted, then we have no other option but look into each and every element one by one. So the searching time complexity will be a function of n, which is the length of the array. If the array is sorted, then we can search the value we are looking for in a log n algorithm, algorithmic time using binary search. What if we have a function that can tell us the location / index of the value we are looking for in an array? We can directly go into that location and tell whether our object we are searching for is present or not in just a constant time. Such a function is called a hash function. In real life, when a letter is handed over to a postman, by looking at the address on the letter, postman precisely knows to which house this letter needs to be delivered. He is not going to ask for a person door to door. All right, here's the hash function, object and index. Hash codes and index, data, hash table. The process of sorting objects using hash function is as follows. Create an array of size m to store objects. This array is called hash table. Find a hash code of an object by passing it through the hash function. Take module of hash code by the size of hash table to get the index of the table where objects will be stored. Finally, store these objects in a designated index. These four steps is the process of storing objects using a hash function. The process of searching objects in hash table using a hash function is as follows. When we try to search for something in a hash table, we using the hash function does this. It finds the hash code of the object we are searching for by passing it through the hash function. Take the module of hash code by the size of hash table to get the index of the table where objects are stored. Finally, retrieve the object from the designated index. And if we scroll down, we find the hash table topic. A hash table is a data structure that maps keys to values. It's a data structure that maps keys to values. Each position of the hash table is called a slot. Slot, the plural is slots, right? Like many slots, all right? The hash table uses a hash function to calculate an index of an array of slots. We use the hash table when the number of keys actually stored in a small relatively to the number of possible keys. Hash table abstract data type, ADT. We use the insert, delete as search. Insert to add object X to the data set. Delete to delete the object X from the data set. Search the object X in the data set. So we go by value. The X is the value always. And here's the hash function on compute hash. A hash function is a function that generates an index in a table for a given object. An ideal hash function should generate a unique index for each and every object is called the perfect hash function. There are many hash functions, properties of a good hash function, and the load factor. Properties of a good hash function, we have 5 properties. It should provide a uniform distribution of hash values. Choose a hash function which can be computed quickly and returns values within the range of hash table. Choose a hash function which is a good collision resolution algorithm. Choose a hash function with a good collision resolution algorithm. Which can be used to compute an alternative index if the collision occurs. Number 4, choose a hash function which uses the necessary information provided in the key. And finally, the hash function should have high load factor for a given set of keys. What is the load factor? Load factor equals the number of elements in a hash table divided by the hash table size. Collisions. When a hash function generates the same index for 2 or more different objects, the problem known as the collision, like a collision occurs. Ideally, hash function should return a unique address for each key, but practically it is not possible. Collision occurs. Collision resolution techniques. To resolve the problem with the collision, what do we do? We have the open addressing and we have the separate chaining. And here is the open addressing. When using a linear open addressing, the hash table is represented by one-dimensional array, which indicates the range from 0 to the desired table -1. One method of resolving the collision is to look into a hash table and find another free slot that held the object which have caused the collision. A simple way is to move from one slot to another in some sequential order until we find a free space. This collision resolution process is called open addressing. Linear probing. In linear probing, we try to resolve the collision of an index of a hash table by sequentially searching the hash table free location. Let us suppose if k is the index retrieved from the hash function, if the kth index is already filled, then we will look for k plus 1 modulo m, then k plus 2 modulo m, and so on. When we get a free slot, we will insert the object into that free slot. This is called linear probing. Quadratic probing. In quadratic probing, we try to resolve the collision of the index of a hash table by quadratically addressing the search index free location. Let us suppose if k is the index retrieved from the hash function, if the kth index is already filled, then we will look for k plus 1 to the power of 2 modulo m, then k plus 2 to the power of 2 modulo m, and so on. So this increases, and we always raise to the power of 2, always. And the result will be divided by m, and the remainder is obtained. This is the modulo function, right? When we get a free slot, we will insert the object into that free slot. Linear probing implementation. Below is a linear probing collision resolution hash table implementation, and this is how we implemented using a class called hash table. Right? And here's the add method, and here's the find method, and here's the remove method, and finally we have the print method. Here's the main menu that calls the class. Quadratic probing implementation, we do this. hash with separate chaining. Another method of collision resolution is based on an idea of putting the keys that collide in a linked list. This method is called separate chaining. To speed up search, we use insert sort or keeping the linked list sorted. Separate chaining implementation, we use this hash table separate chaining class. This is how we implemented all the methods and details. All right. Count map. Below is count map T implementation over C++ collision hash table T. This interface is important if you have to repeat values, I think this is repeat values, can come and you want to keep track of their count. So we have count map, if we want to keep track, right? Problems in hashing. Anagram solver. An anagram is a word or phrase formed by reordering the letters of another word or phrase. Two words are anagram if they are of the same size and their characters are the same. Remove duplicate. All right. And here's the solution. We can use a second array or the same array as the output array, and the below example hash table is used to solve this problem. Remove duplicate. Right? Find missing. There is a list of integers. We need to find the missing number in list. Find the missing. Here we go. Print repeating. Print the repeating integers in a list of integers. So just print the repeating. All right. Print first repeating. Here is the implementation. And we have the chapter exercise. And exercise 3. And exercise 4 and 5. And 6. And we are done with chapter 12, and in the next video we'll talk about the graphs, chapter 13.